before you look at how I solve problem 5, I suggest you to practice on this problem first, because this basically culminate what we learned so far for today's lesson. So if you can solve problem 5, I think you should be able to get on the concept we learned in today's class. And of course, in every single lesson, I have an additional practice problem. For example, in this case, we have 4.1, 4.2, and 4.9. You will solve by your own, and the solution already on Canvas. And that what I did in a face-to-face class. So we will not practice that. Basically, consider that the homework, but ungraded. You check by yourself, and that will help you to prepare for the quiz and exam in this class. Solution on Canvas. Check yourself. So, like I said, practice problem 5 before you watch. Yes. Problem 5. A front-end loader has an output of 150 BCY common earth per hour, and it load at a fleet of 6 trucks. The capacity for each truck is 20 LCY loose cubic yard each, and it haul to fill a compacted with the shrinkage percent 12%, and each truck had a total cycle of 35 minutes, and assuming it does not have to wait in line to be loaded, so it means the operation will be smooth. 6 trucks just go good in line to get it and don't have to wait. And the 12% for this common earth is 20%. And the chop required, the volume of the chop required, as you can see here, is 50,000 CCY. The question is how many hours will be required to excavate and haul the material to the field, to the compacted areas. So this one, as you can see, the operation of the 2 types of equipment. The loader basically dig, excavate the material, put on the truck transport that material to the field areas, to the compacted areas. So that 2 equipment have to work together, and that we need to find out how many hours to complete the job. So when you have multiple coordination of different equipment or different people, we need to first find out what is the production or the productivity for each of equipment or each of material. So there is 2, so I will also do the same in here. We need to find out what is the production rate of the loader and what is the production rate of the a fleet of 6 trucks. So first one, standard. Production rate of the loader. So they already give us 150 BCY per hour. So we can have the equation here, R, and in this case the loader, I call it RL, it equal to, it already given, 150 LCY BCY band cubic yard per hour. And because the truck in loose cubic yard, you may consider to change that into loose cubic yard. So if you recall, it will be 150 BCY, and then we have to time the percent well. So 1 plus 12%, so that the volume increasing, and that is 20% that you have it in there, 20% here. So you will have that RL equal to 150 times 1 plus 0.2, so it will be 180 loose cubic yard per hour. We need to have a same unit to compare. So that is the standard production rate for the loader. How about the fleet of 6 trucks? We do the same. Standard of the fleet of 6 truck. Not one, but 6 of them work together. So in this case, I call that the R truck, actually 6 truck, right? So it equal to C, and you can see C over T, right? In this case, you can say C truck over the cycle time of the truck. We have 6 of them, so you have 6 truck. Cycle time for cycle capacity for each truck is 20 loose cubic yard, so you have time 20. Divide by cycle time for each truck. Time for each truck. We have here 35 minutes. That's what we have. And we want to change that into per hours. So you will have 60 minutes per 1 hour. So from here, we can have 206 LCY per hour. So for 1 hour, loader can excavate 120 loose cubic yard per hour. For 1 hour, a fleet of 6 trucks can carry 206 LCY per hour. So you cannot add totally, they will complete 180 plus 206. It's not about that, because we need to consider what is the bottleneck here. Who is slower? That the machine or the people at a slower speed actually control the whole process, and that we call the bottleneck. So in this case, as you can see, regardless of the truck work very hard, the loader slower, it will dictate the operation of this excavation work. So with that, we have to reason here, because the production rate of the loader is lower, right? Is lower. So basically, that is constrain the operation. It constrains the operation to a maximum output of only 180 LCY per hour. So basically, that is the bottleneck. So from that, we can know what is the production rate for this whole system, 180 LCY. We need to know what is the quantity of the chop, then we can find out the time. So we have the chop volume that give us already. We need to change the unit, 50,000 CCY cubic yard, compacted cubic yard. And to convert to the bent cubic yard, we need to divide by shrinkage factor. Okay, so let's go back to review what we learned in that equation here. Shrinkage percent equal to 1 minus shrinkage factor. So shrinkage factor equal to 1 minus shrinkage percent. Okay, and from that we can find out the it change to BCY. For this one, I can say that it equal to 50,000 1 divided by shrinkage factor. And if the problem don't give you the number, you can go to the table in the reference or the slide that exam reference on the slide that I showed earlier. So here we can have that equal to 50,000 1 shrinkage factor percent square. So we have it point the square percent in this shrinkage percent 12%, as you can see there. So 12. So from that we can get equal to 56,818 BCY. We are not yet. We LCY. We need to do one more step, right? So from that 56,818 BCY, we need to do something like here, 1 plus percent square to get the LCY. So we have 1 plus 12%. So what does that mean? We have 56,818 times 1 plus 0.2. So you will have get 68,182 and the unit is LCY. So we have the volume. You have the volume. We have the production rate. So LCY per hour, LCY, you just get the volume divided by the production rate. Then you can get the hour needed. So from here, we can get the hour we need. So we have the number of hours required. To excavate and haul the material to the field, and that equal to see here, the number hour T equal to the quantity volume 68,182 LCY divided by 180 LCY per hour. So LCY cancel out, so you have hours. So the answer it will be 379 hours. And then if you work 8 hours per day, you can go ahead to divide 8 hours. You know how many days. So multiply, as you can see, we combine all the concept for years to work on this problem. And again, go ahead to practice for 1, 4, 2, and 4, 9.